Sets. We're going to look about set language, notation, and the Venn diagrams. Venn diagrams are a way of representing sets. Intersection. Let's have a look at the intersection. So here we have two sets. Now, a set is represented by a circle on what's known as a Venn diagram, and they have a capital letter A. We always use capital letters. So this set here represents B, and this set here, the rectangle, represents the universal set. Now the universal set is everything which could be in a set. So we could talk about this. All the students in this class could be called the universal set. Set A could be the set of girls, and set B could be the set of boys. Right, shading, and we want to find what's known as the intersection. If I shade A like that and then shade B a different way, then the bit which is double shaded represents all the elements of the sets which are in A and B only. And this is called the intersection. And we have a special symbol for intersection in set notation, which is this little N. So this means A intersection B, and what is represented is the shaded area here. Okay, if you shade both sets in, then it is the double shaded part. Intersection means everything that is in both A and B. Union. If we do exactly the same thing as we just did before, we shade A and we shade B, then everything which is in shaded will represent union. Okay, so if we just shade it once, everything which is shaded, so it doesn't matter whether it's been shaded once, twice, or once, it's counted for union. Okay, and therefore the symbol we use for this is like a U. Okay, so this is A union B. Union means everything in A and B and in both A and B. You only count anything only once only. Okay, you need to be clear on those two facts. What is intersection and what is union? Subset. Here we have A completely in set B. So set A is represented by the inner circle here, and set B is in the universal set. Okay, the symbol we use for this is A is a subset of B, is this one here. Okay, if we have, in this case where we have a line through it, it means that A is not a subset of B. Complement. Now, we've just told you that A union B would be everything that's in this bit, everything that's in this bit, and everything that's in this bit. If I want not that would be this bit shaded here, and that would be represented in set notation by this A union B, but not it, and we put a little line here to mean not. So A union B, not. This means all the elements which are not in A or B, or both in this case. Right, so that's complement. The other two things which you need to think about carefully are this. If I was to shade in A, that would be represented by the red shaded region here. If I shade in not B, that will be represented by the blue part here. Now the double shaded bit here, the bit that's been double shaded, so the things in A only, you can think of it as this bit here would be the intersection. Okay, so this red bit here, and this diagram over here, which has been done once, A intersection not B will be this area only. This diagram here is to help you to get to this diagram. Okay, so remember, the rule is for intersection, been shaded doubly or double shaded when you've got two sets. Similarly, if I was to shade in B, that would be that bit there, and then not A, that would be here. Then this bit here, which is double shaded, everything within that area there is double shaded, would be called A, not A, intersected with B. Alright, which gives me that shaded region here. It's a way of getting any the elements in A only, or the elements in B only. Right, here we have a Venn diagram, and these are the actual elements of the set. So we've got A, B, C here in A only, D, E in the intersection, F, G, H and I in B only, and the J not in A or B. Right, if I had to list the universal set, then I need to list every element in the set. When we list elements of a set or describe a set, we put it within curly brackets like these, and then I list each element, A, comma B, comma C, with a comma in between each element. So in A, we will have A, B, C, and D and E, because these are also in A. Okay, so here we have A, B, C, D and E. In B, we would have D, E, F, G, H and I. In the intersection, we're just going to have D and E. In the union, we're going to have A, B, C, D, E, F, G, H, I. What's in A and what's in B and what's in both. We only list each thing once only. Okay, A union B but not it, so it's everything which is not in this area will just be J. And A intersection not B, this is the elements which are in A only, so it's A, B and C. Remember back to the previous slide. Okay, and these are the elements which are in B only. A, not A, intersected with B will be F, G, H and I. Alright, you should carefully study these two, because these two are the ones which cause difficulty. Right, if we have a different type of Venn diagram, if you have a look at this for 1 minute, maybe pause the video and see how this diagram is related to this diagram. So if you want to do that, pause the video now. Okay, you should have realized that this stands for, this time, the number of elements in a set. So we have 3 elements here, 2 elements here, 4 elements here and 1 element here. If we look here at these, we have 4 here, we have 2 here and we have 3 here and 1 outside. So going through all these now, so the number in the universal set will be number in everything, 3 plus 2 plus 4 plus 1, which is 10. The number in A will be 3 and 2. Don't forget the 2 is also in A, it's 5. The number in B will be 2 plus 4, which is 6. The number in A intersection B will be 2. The number in A union B will be 3 plus 2 plus 4, which is 9. The number in A union B but not it just is 1 outside. The number in A intersection not B, this is A only, which is going to be 3. And the number in not A intersection with B is going to be 4. Okay, so 2 types of diagram. These are the elements of the set, of the actual elements, and this is the number of elements in the set. Notice, because we're talking about the number of elements in the set, we do not put the answer into brackets. Here we talk about the actual elements of a set, so they're put into brackets.